Okay. I'm Mark Gingrass, and I work on Tinker Air Force Base. We are trying to stand up a data science and analytics flight. Most of us have a background in using government type tools like Excel and Microsoft Access. So one thing I wanted to do was learn Python and try to maybe bring that into our flight. To do that was kind of difficult because we can't have Python on the base. But I still wanted to learn it and try to bring whatever I can to support my flight for later down the road. I signed up for the self-driving car nanodegree program to try to motivate myself to just jump right in and learn Python, learn a little bit about machine learning, about image detection, and about all these different things that seem to be really cool and high tech. I'm trying to break into the tech area. So what I'm going to present to you today is my first project that I finished in this Udacity self-driving car program, but I'm also going to give you a little background to where I come from. So I have an academic level C++ knowledge from back in the day, which was the year 2001, maybe. So I did take some C++ courses, so I have some actual understanding of object-oriented programming and how the syntax works and all that stuff. I've taken courses such as linear algebra and all the calculus courses. But what really got me motivated to want to learn this type of field is I just finished a machine learning and data mining graduate level course at UCO. My mind was blown, and I've been hooked ever since. That course definitely got me pumped up and motivated. But this is my background. I don't have a STEM-related degree. I don't have a computer science degree. I've never been a programmer or a developer for any commercial company. So that's my background. I joined this Udacity self-driving car program thinking I might be way in over my head. And the intros to that program, everybody there was a PhD with some sort of, I do self-driving cars in my sleep. And it was a little bit intimidating. But let me show you what I did and how to actually find the lanes on a road and how easy it actually is. So if anybody wants to break through that barrier, you know, this is what it's all about. So I'm going to run you through these 9 steps. And steps 1 through 8 is what you do to an image. And it's going to be, I'm going to describe these. And step 9 is let's take that and apply it to every frame in a video, which is nothing more than a lot of images. So I'm going to run you through this code, or the actual pseudocode, or the talk, and why we do these different functions with the picture. And maybe that'll motivate some of you to learn more about this and start your Udacity self-driving car nanodegree program. So we start with an image. Everybody's seen images like this, especially with cars nowadays. They already show you where the lanes are. So I have a set of images that are, there's a scale 540 by 960 by 3. The 3 is the 3 channels of colors, the RGB, and I believe those colors can be from 0 to 255. So you have a lot of choices there for colors. And we convert that image to a NumPy array, so it's really nothing but a series of numbers. So the image, the computer only sees numbers, and forgive me, I am not an expert with image analysis, and I do use a lot of libraries if I can, because I don't know Python very well, yet, but I'm motivated by the first lecture to do what he said and try something outside of my comfort zone. So first thing we do is we want to reduce the colors, because it turns out that if you reduce the colors, you can save a lot of computational power. Your GPUs are going to be held to the max if you use color. And it turns out also the model complexity is going to be a lot easier with fewer colors and fewer dimensions or whatnot. The luminosity, I read this on the internet, luminous actually has almost nothing to do with feature detection. So the color itself is actually more noise than not noise for these simple models. I'm sure some future models will say otherwise, but from what I read, color is just noise, so let's get rid of it. Let's make it simpler. So then the next thing we do is we apply this thing called a Gaussian blur. Now these are all just simple one-line functions, which I'll show you here in a minute if we have time. But what this Gaussian blur does, it averages the colors. Picture taking like a 5x5 plot of pixels and saying, hey, what's the average pixel number for that? And if, let's say, for example, the numbers could be between 0 and 8 as far as what kind of grayscale it is. And excuse my lingo, I don't know the proper terms for this, but if you have a bunch of 8s and 7s and 6s, it'll average them out, and it'll make all of those pixels in that little plot all the number 5, whatever the average was. And so far throughout the entire picture, right? And I'm going to tell you why we do that. We're going to do that because we're going to do something called canny edge detection. So once we let me go back here. If you can see the difference between the pictures on the left and right, the one on the right is more blurred because those pixels have been averaged. And so we average them because we're going to apply this thing called the canny edge detection. And we set these thresholds. Basically, what you learn is, throughout this course, is that as you move from one pixel to the next, to detect an edge, what we're going to do is we're going to say, if the color is an 8, and then an 8, and then an 8, we can consider those connected. But we have a threshold. Say, well, maybe a 7 is still good. But once you get down to 6, no longer consider that an edge. So that's why we average them out, because if you zoom in far enough, every pixel is going to be slightly different, and you're going to run into some trouble. So that's the basics behind that. And once you detect the edges, if you look on the picture on the right, that's quite a few edges, a little too many to deal with. So let's fix that by cleaning it up a little bit, and we define a region of interest, or an ROI. We narrow the scope of what we're doing. This is good for a couple of reasons. One, what we're going to do is we're going to set a polygon around where you think the lanes should be, because typically what you have in self-driving cars is a camera mounted onto the hood, and it's fixed. So your lane's going to be in roughly the same position. So we actually draw a trapezoid around where you think the lanes are going to be, and we only worry about that. So it also saves you computational power. And so after that, we want to average and draw the lanes. How do we do that? We use something called a Hough Transform. And what Hough Transform is, it'll take all these line segments, and you can set thresholds to see, hey, is this actually a line? Then you've got to figure out, well, is this line sloped this way or that way? So you know it's a left or a right line. We do that through a bunch of averaging and a little bit of algebra manipulation. So there's not too much math in this one, maybe a little bit of trig and angles. One thing that really throws me for a loop to this day, and I haven't played with it too much, is the fact that the positive y-intercept is going downward. I'm still, in my head, hasn't figured that out when it comes to angles properly. But so we apply this to a video using another simple one-line function. We display the picture over the other picture with a transparency parameter. Okay, so now let me show you the code. And just this code is not very elegant, but we have our imports. To display the images, I have a small snippet of code here that just goes through a for loop. It checks the directory for images, and it shows you the various images that I have. So I repeated the code, not the proper way, but I just cut and pasted it for this demo. But now I'm going to show you the grayscale, and I'm going to run through this, and we'll run a video here in a minute. So this is the blurred grayscale. Oh, I'm so sorry, guys. Well, that doesn't help. Let's see. How does this work? Oh, I see. Swap displays, maybe? Yeah, let's try. It's that presentation mode, maybe. Let me close this. Say again. Okay, let's go back. I'll be quick about this. I'm not sure on the time. So we have the code, and basically what I have here is, I know you can't read the code or want to look at it too hard, but it's a for loop that just goes through each picture in my directory, shows the pictures because you have various pictures to try this on. Try it on pictures first, then we have the grayscale, and we go down. And this looks like a lot of code, but it's one line that, like this line 7, the Gaussian blur, one line. The rest is just going through each picture, so I can show multiple pictures. So really, each one of these frames are going through just one function at a time. And this is the edge detection without the region of interest. And you keep going through, and we have the edge detection with the region of interest with various pictures. And finally, we should have there's the markings that we decided on. And I want to show you the video output. So once you run this through the pipeline, hit play, and there's your drawings on each frame. And it's relatively quick with my CPU on here to run this video, to compile it, so to speak. It's only a short clip, but it takes maybe 4 or 5 seconds. Now, obviously, I'm going to have to learn how to do this in real time if you want to use this on a self-driving car. Let me show you the challenge video that did not work, and this is what I can use to maybe do some more math and figure it out. So you don't want to drive in this car. So basically, I wanted to tell you guys about my self-driving car experience so far. From a guy that didn't know Python at all when I started, maybe 3 months worth of Python installs, learning how to use GitHub, all these different tools. All those tools out there take a long time to learn. That's probably the hardest part is how do you actually install it? What is an environment? You know, what is Python 2.6 versus 3.6, whatever it is. So that's probably the hardest part for me was the actual configuration and the tools. The next things that this will go through is we're going to do lane sign detection. So we're going to use TensorFlow and image recognition based on machine learning. So I'm excited for that. And then we get into some more advanced lane detection and car detection. And that is just the first of a sequence of semesters, so to speak, for this Udacity deal. So without further ado, I think I'm done with this one, and I'll take questions afterwards.